Hello, my name is Tomoaki Riku, and this is my midpoint video walkthrough. I will be explaining how my mesh implements variable expansions and definition. So I would like to start off by presenting some simple examples. If you could please take a look at the terminal, I will define a variable one named variable one as one, variable two as two. And this allows to do something like the following: echo variable one, which returns one, and we could even expand two variables at once, which would return one and two. Such variable definition is handled by a function called store var, but before that, we need to take a look at this header file. The header file defines a variable called max sterling, a constant at 128, and also three things that are defined externally, which are rlen, which keeps track of the sizes of these two arrays, and these two arrays, var and values, are parallel arrays. So for instance, the variable named at index I in var I is defined by the value stored at index I in values. So how store var is implemented. To store variables, we first need to check if there's enough memory allocated in these two arrays that we talked about. There's two scenarios for this. The first scenario is memory has never been allocated before, so the function uses memory allocation and allocates new memory. How much new memory was allocated is kept track by rlen. If there was memory allocated before, but if it was used up, then we would just have to allocate new memory without modifying the previously stored values by using reallocate. The amount of new memory allocated is kept track with rlen. And then it traverses, once we know that there's enough memory, the function traverses through the array var to find the variable name that it was given as an input, var name. If it finds it, we redefine it in the values. If we don't find it, we define it newly by adding the name in var and adding its value in values. Uh, Next, alternative implementation with this would be to struct a new variable that can store both the variable name and its value. And I realized that this is a viable option while I was implementing my current implementation, but after analyzing it, it did not change the space complexity or the time complexity of the algorithm, so I chose to keep my current implementation. An unviable implementation would be to use the stack, because stack cannot allocate memory dynamically, so it wouldn't meet the requirement of us being the mesh being able to store arbitrarily many variables. So next, I'll talk about how variable expansions are implemented. Okay. I will now talk about the expansion of variable, not declaration of variables. The expansion of variables are handled by a function called expansion var, and it receives a tokenized command, so there's no white spaces. And so it could look something like the terminal, like $ for one or $ for one, $ for two. And there could be arbitrarily many variable expansion in a single command that it receives as an input. Firstly, it tokenizes it using the $ as the delimiter. And it traverses through the tokens. Then it uses a helper function called find var value, which essentially traverses through the two parallel lists that we talked about, finds the definition of the variable, and then keep concatenating it while traversing the tokens. And if it does not find if the helper function does not find a definition for the given variable name, it just returns an empty string like the requirement asks us to do. It makes sure that the maximum length does not exceed 125, because the resulting string that we're concatenating to, that's declared at the start, uh, has a maximum size of max sterling, which is defined as 128. And when we concatenate it using start and cap, we calculate the remaining slots available by doing 127 minus the length of the resulting string. before concatenating this new string. So whether it is empty or whether we found a valuable definition, we always keep track of how many slots are left. And an alternative implementation of this would be to not use start talk and traverse the variable expansion like $var1 or $var2 that we receive. Once we find $sign, and then if we encounter an end of a string, white space, or another $sign that leads to another dollar expansion, we parse the whatever is in the middle. So for instance, var1. But start talk library function does exactly the same. So for the sake of code refactoring and readability, I decided to use start talk. Okay, so if you could please look at the terminal again, we will take a look at a more unique example. Let me define a variable called student number, 1234, and student name. I'll use my name, Tomo. Then if we do student number equals dollar student name, it doesn't cause an error. And what it essentially did, if we can check using echo, if we expand the variables 1234, it gives Tomo. What happened is student number was defined, student name was defined, and then a completely different variable was defined using the definitions of the previously defined variable. And I'm going to talk about how this is made possible in the function variable expansion var. Once it receives expansion var, it checks if it's also a variable declaration using the helper function is var declare, which is simply checking for an existence of an equal sign in the command. If there's an equal sign, it's actually a combination of two variable expansions. If we take a look at this example, there's an equal sign in the middle, so it's defining some sort of variable, but the left side and the right side are just two variable expansions. So we solve this recursively. We create a string that can contain 128 characters for the left side and the right side. We tokenize it using the equal sign as the delimiter, and we do expansion var for the left side and the right side. And we took a look at how this was implemented. So what it essentially does is the left side, in this case, student number is replaced by 1234. The right side, student name, is replaced by Tomo. And now we have the left side expanded, right side expanded. So now we just have to check if the addition of the left side equal sign of the right side exceeds 128 characters. If it does, we can just display an error saying that variable name and value are too long. Else, we can create a resulting command that's maximum 128 characters long, append the left side, equal sign, and the right side, and then we have the command that's ready to go. So what the function essentially did is expand the left side to 1, 2, 3, 4, expand the right side to Tomo, concatenate it. So the command that the mesh essentially parses is 1, 2, 3, 4 equals Tomo. And that's why after we declare it in such way, if we do echo $1, 2, 3, 4, we get Tomo back. And lastly, when we parse a given input, it expands the variable first and then declares the variable, declares all the variable. And the reason why we did that is to make this previous example possible. If we declared it first without expanding anything, then this literally, so $sign student number will be will define to $student name. And that's not the implementation that we were requested to do. We were requested so that these kind of command and variable definition works. So that's why at the high level, we need to expand everything first and then define if there's a definition still left. Yep, that is my implementation of variable definition and variable expansion in my project. Thank you.